Hi dear students, good morning. This is your Shalom Sai Krishna. Welcome to our school YouTube channel. Today in this class we have to discuss the types of mirrors. As in our everyday life we have the different kind of the mirrors. First one plane mirror, next one is spherical mirror. First we have to discuss about the plane mirrors, how we can make the plane mirrors. We are making the plane mirrors by the using the glass. So how we are using the glass and how we are converting into the mirror. Simply the glass is a transparent material. In the previous class we already discussed, when we send the light rays into the glass, it will be transferred from one side to another side. Yes, we have to consider as a glass, as a transparent material. But when we keep the coating like this, what is here appearing is it is in a coating. Yes, at the time the glass is converting into the mirror. At the time when you send the light rays, at the time there is no chance to move one side to another side. It will be go back. Is like this. That means simple changes are there. The glass mean transparent material, mirror mean non-transparent material. Glass can be transfer the light from one side to another side, but mirror cannot transfer from one side to another side. It can be reflecting the light rays. Yes, what it can do? It can be simply reflecting the light rays. When the light rays are fall on the mirror, it will be move back. Yes, that is a major difference, simple difference in between the glass and mirror. Sir, here you made the coating. Yes, I made the coating. How I made the coating? That means I used here silver bromide chemical. Which one? Silver bromide. The symbol of the silver bromide is AgBr. Yes, by the using of the silver bromide, just I converted that glass into the mirror. Simply we have to keep the behind of these glass only. Yes, now it become as a mirror. Nowadays we are not using this silver bromide. What we are using nowadays? Aluminium we are using as a coating. Why we are using the aluminium? It's nowadays because of this aluminium is low cost compared to the silver bromide. The symbol of the aluminium is Al. When we compare with the silver bromide, aluminium cost is very low, and it's also not allowing the light rays from one side to another side. That's why we are using the nowadays aluminium as a coating for the mirror. Yes, just we made that mirror. When you stand in front of the mirror, at the time which kind of the properties will be appear? In every day you are standing in front of the mirror. Yes, for dressing, for your makeup, for your combing, for whatever it may be, you are standing in front of the plain mirror in our everyday life. At the time some kind of the situations about we have to discuss. Yes, what kind of the changes will be happen, that we have to think. Suppose you are here. Yes, when you stand in front of the plain mirror, it is in a plain mirror. You are here. Yes, inside this there is an appear that image. Yes, here image is appear. It is as usual. Is there any change? No change. Simply you have to see here the green color, here also green color. Yes, everything it is same to same. There is no change. That means simply we have to consider as a twins. These two members are in a twins, yes or no? Same, identical, there is no change. First property, what is the distance from this your place to a mirror? Suppose 2 meters distance is there. What is that? Simply you have to assume 2 meter distance is there. It is an object. You are the object. Distance from the object to mirror is 2 meters. At the time, image will be appeared inside the mirror. At the time, what is the distance in between of this image and the mirror? At the time also same distance. Yes, we have to conclude that concept. Distance from mirror to object is equals to distance from mirror to image. Both also same. Here the 2 meters, here also 2 meters. There is no change. Sir, I don't want to stand at 2 meters distance. Just I wanted to stand at 1 meter before in front of the mirror only. Yes, you have to stand in front of the mirror as a 1 meter distance only, with 1 meter distance only. At that time also, image distance also 1 meter. There is no change. As always, it will be the same. What is the distance of the object from the mirror? That is always equals to the distance of the image from the mirror. There is no change. That is the first major property that we have to keep in the mind. Next property is here special characteristics. Left hand of our left hand is appear as a right, otherwise right hand appear as a left. Is you are here, you are standing in front of the mirror, your right hand is appear as a left appear as a right. This is a basic most important information. When you stand in front of the plane mirror, at the time always right hand appear as a left hand appear as a right. This is we have to know as a lateral inversion. What is that? Lateral inversion. Which inversion? Lateral inversion. Yes, lateral inversion we have to consider. Right appear as a left appear as a right. That property we have to know as a what? Lateral inversion. Next property we have to check is here. Again one. Suppose you wanted to see total your image in the mirror from top to bottom, heads to up to the legs only. You wanted to see your total image in the mirror from top to bottom. At the time, suppose your height is 6 feet generally, but that 6 feet height is there. What should be how the size of the mirror? You want to see your whole image in the mirror. At the time your height is 6 feet. At the time the mirror height we require at least compulsory 3 feet only. Otherwise you can't see your whole image in the mirror. What I am telling is you want to see your whole image in the mirror mean that mirror size should be half of your height. That mirror height should be half of your height. That means your height is 6 feet. That mirror height should be half as a 3 feet. Otherwise you can't see your whole image from top to bottom. You want to see your whole image from top to bottom. Your height is suppose 6 feet, mean the mirror height should be half as a 3 feet. Sir, my height only 4 feet, sir. Yes, you require only 2 feet, sir. Sir, my height only, sir, 3 feet, sir. You require only 1.5 feet of the mirror only. At the time only you can see the whole image only. Yes, first property what I told, distance from mirror to object is equal to distance from mirror to image. Second one, lateral inversion, left appear as a right and right appear as a left. Is third one, half of the height of the mirror is required to see your whole image only. Next one is when you run in front of the mirror. Suppose you are running in front of the mirror 2 meters per second. Is what is your velocity? Your velocity is 2 meters per second. In 1 second your velocity is 2 meters. Is your image velocity will become as a double, is 4 meters per second. Is it is the most important property when you run in front of the any plane mirror. At the time your velocity will be become as a double. That means your image velocity is always double than the object velocity. Your actual velocity is 2 meters per second, but the image velocity will be appear as a 4 meters per second. There is no change. How many meters per second? 4 meters per second, because of it is becoming the double. It is becoming the double. Next one, here one more concept. Here height of the object is equal height of the image also. There is no change. Suppose your height is 5 feet are there. At the time image height also 5 feet only. There is no changes. His height of the object is equal to height of the images only. Once more I'll repeat that all properties. First one, distance of the object equals to distance of the image. One property. Second one, lateral inversion. Right appear as a left, left appear as a right. Third one is when you run in front of the mirror. When you run in front of the mirror, the velocity will become as a double. What will become as a double? Velocity will become as a double. Again one, distance of the object and distance of the image from the mirror, both also same. Object distance from the mirror, image distance from the mirror, both also similar. Again one, I told you want to see your whole image. At the time you required half of the height of the mirror you have to require. These are the major properties of plane mirror. Here one more question I can raise here. When you stand in front of mirror here, you are at outside. Your image is inside. How many images are appearing here? Only one image only appear. Always you have to see when you stand in front of the mirror. At the time what will be happen? Only one image will be appear like that only. Why the one image only appear? Its properties are like that. But what is my question? I wanted to see my more images. Just I am only one single person, but I wanted to see more images. Is it possible by the plane mirror? Yes, it is possible by the plane mirror. Not only with one plane mirror, by the using of the two plane mirrors, it is any possible. Just we have to see here. Is here how many plane mirrors are there? Two plane mirrors are there. Here the candle is only one of the object, but here one image, here one image, here one image, here one image. Overall 4 images are appearing. Object only one, but images are how many? Images are 4. How it is possible? Is two plane mirrors we have to keep beside each other by the making some angle. By the making that what? Some angle. Is it is only one plane mirror? It is only one plane mirror. One and two plane mirrors are there. These two plane mirrors we have to keep each other by the making of the some angle. Yes, in between there is a some angle is here. Is like this making some angle. If we keep the two plane mirrors, it can be give the more number of images. That depends on the angle, the number of images will be changed. That means simply we have to keep in the mind number of images of formation is depends on the angle between of the two mirrors. Angle between of the two mirrors. If the angle will be changed, number of images will be also changed. Like these arranged two plane mirrors we have to consider as a inclined mirrors. Inclined mirrors. Which mirrors? Inclined mirrors. Two plane mirrors are keeping each other beside them by the making some angle, that we have to know as a inclined mirror. Which mirror? Inclined mirrors. Yes, by the using of the inclined mirrors we can get that more images. How many number of the images we can get by the which angle? Let us discuss about that one. We have that one formula. Is see here the formula is n, that is equal to 360 by theta. N that is equal to 360 by theta minus 1. N that is equal to 360 by theta minus 1. Here one condition we require. N that is equal to 360 by theta. Here 360 by theta is even number. Which number? Even number, like that 2, 4, 6. 360 by theta is equal to even number. At the time we have to subtract the -1. At the time getting value only our answer. What I am telling? N that is equal 360 by theta. If it is even number, at the time only we have to make -1. Suppose if it is odd number, n that is equal 360 by theta is odd number, maybe 3, 5, 7, like that. Yes, that is only the answer. No need to subtract the 1. No need to remove the 1. If it is value 360 by theta, if it is even number, at the time only we have to make the -1. Otherwise no need to make the -1. Yes, if it is directly odd number, yes, 360 by theta is only directly odd number. At the time that odd number only the exact value. Let us try it once. Is two mirrors are arranging in which way? Is by the keeping the 60 degrees angle. Two mirrors are keeping with the 60 degrees angle only. At the time how many images will be formed? How many images will be formed? Theta that is equal to what? 60 degrees. Yes, what is the formula? N that is equal to 360 by theta. That's mean in the place of the theta I am keeping that value is 60. Yes, here always formula -1. 0, 0 cancel. 6 1s are 6 6 are. Yes, here the 6 is even number. 6 is even number. Now that's why we have to -1. 6 -1, that is 5 images will be formed. If the angle in between the two plane mirrors is 60 degrees, at the time it can form how many images? It can form the 5 images only. That also we have to keep in the mind. Yes. Next, if the angle in between the two plane mirrors is 40 degrees, at the time how many images will be formed? N that is equal to 360 by 40. Yes, 40 -1 as usual. 0 0 cancel. Here 4 1s are 4 9s are. 9 is a odd number. Which number? Odd number. At the time no need to make the -1. Only this odd number only the answer. That's mean how many images will form? 9 images will be formed when the angle in between two plane mirrors is 40 degrees. Yes, odd number mean no need to make the -1. Here one more exceptional case I can tell you here. When you go to the hair salon shop, here one plane mirror is there, again one plane mirror is there. You are sitting in front of these, any one of the plane mirror. Yes, these two are parallel to each other. In between there is an angle is 0. Is there any angle? There is no angle. The angle is 0. Two also parallel to each other. Yes, opposite, quite opposite to each other, like this. Yes, at the time what we have to do? How many images will be formed? Yes, at the time infinity images will be formed when the two plane mirrors are opposite to each other, parallel to each other. Is there any angle in between of these two? There is no angle. 0 angle only there. How many images will form? Infinity images will form. Just you have to assume when you go to the hair salon shop, just you are sitting in front of the one plane mirror. Behind of that mirror, so many images will be appear. So many, lots of images will be appear. As usual, these concepts also we can see at the shopping malls also. They can keep the two plane mirrors in the parallel manner, parallel to each other. Is when you stand in front of any plane mirror, so many of the images will be appear at once. This is one of the exceptional case. This is the complete information about the plane mirror. By the plane mirrors only we are making the inclined mirrors only. Next concept about the spherical mirrors. Yes, it is a spherical mirror. By the using of these spherical mirrors, we have to make the concave and convex surfaces. Suppose this is completely spherical mirror only, a spherical mirror. Yes, by the using of the spherical mirror, we are making the concave and the convex. Both also we are making by this. How we are making? Suppose we require concave mirrors. Yes, concave mirror mean like this. Yes, behind of this side we have to make the coating. Behind of this side we have to make the coating. It should become as a concave. Suppose we require convex. No, at the time what we have to take? We have to keep the coating as a inward side, same as usual, but inside we have to make the coating. Now it become as a convex. Yes, because of this outward is in a reflected area. This side is reflected area. This side is reflected area when we take the convex. Suppose if we take the concave, see, concave mean inside area, inward area, only the reflected area, this area. Yes, that is a major difference of the concave and the convex. Just we have to see some of the example about the concave and convex mirrors in our everyday life. Just you have to see here our spoon, regular our teaspoon only there. Yes, this inner part is work as a concave. Yes, outward appear as a work as a convex. A spoon one side is concave, again one side is convex. Daily you are using this teaspoon. Yes, at the time you have to remember inward is always concave, outward is always convex. Yes, next example we have to see here. Yes, here concave, the shaving mirror is concave. Yes, here it is in a convex mirror only. Yes, that we have to keep in the mind, it is in a convex mirror only. Yes, not only this, some other also we have to check. Here the dentist, what they are using, that is in a concave mirror. Yes, next in the parking area they are keeping, yes, parking area only they are keeping, that that things we have to consider as a convex mirror only. Convex mirror only. Not only this, your glass. Yes, what you are using for drink the water, that glass, inward area, suppose like this inward area work as a concave, this outward area work as a convex. Yes, in our house wash basin also having like this, inside the wash basin concave, outside the wash basin is convex. Yes, as usual globe is, when you take the globe from our school, just you have to observe this outward work as a convex, is inward work as a concave. Like that, so many of the examples are there about the concave mirror and convex mirror in our everyday life. Yes, one concept we have to remember, most important point you have to note it is here, radius of curvature for concave mirror is positive. Radius of curvature for concave mirror is positive. For this convex mirror is negative. Radius of curvature for this is positive. For this convex is negative. Yes, and we have to remember, is concave mirror can form the more real images. More real images can it form. Yes, it can form the more virtual images it can form. Which images? Virtual images it can be formed. Yes, more real images it can form, more virtual images can form. A small object appear as a somewhat big. A small object appear as a somewhat big and clear. Here big object, large size object appear as a small in size. Small in size it will form. Is this concave mirror in our everyday life? Is vehicles headlights in we are using. Is and telescope in also we can use. Most important, telescope in we are using. Yes, these convex mirror we are using in the vehicle side mirrors. Vehicle side mirrors in we are using this convex mirror. Yes, most important, most important. These mirrors which we are using in the vehicle side, yes, that we also known as a rear view mirrors. That we also known as a what? Rear view mirrors. Rear view mirrors. Which mirrors we are using in the side mirrors of the vehicle, that means convex mirror, that we have to know as a rear view mirror. Why like that? Means suppose just we have to discuss about that concept. Here your vehicle is here, suppose like this, your vehicle is here, some other vehicle is there behind of you. Yes, the side mirror in it is up here. This image will be formed in this mirror. That means this big size image appear as a small. Again, far away object appear as a very near. Large size one appear as a small. Far away appear one as a near. Yes, again one erect image will be appear. Erect image will be appear. Three concepts most important we have to remember. A large sized one becoming as a appear as a small. Yes, far away object appear as a very near. Again one erect image, that means always tires should be appear as a downward only. Yes, tires should be appear as a only downward only. Small, near, erect by the convex mirror. That's why this convex mirror we have to consider as a rear view mirrors only. What is that? Rear view mirrors only, most important. Yes, in our side mirrors in they are giving, writing and giving objects in the mirror closer than they appear. What I am telling? Objects in the mirror closer than they appear. That means if the objects are far away from us, but it is appear as a very near only. That's why they are right and giving objects in the mirror closer than they appear. Suppose here I am writing, one of our students is he forgot to keep the convex mirror in the side mirror. Just he was keep that concave mirror. At the time, what will happen? At the time, this large object may be appearing as a large size only. Yes, far away object appear as a far away only. Yes, again when these tires will be reversely, yes, tires will be appear as a up, head will be appear as a down. Yes, inverted image maybe it will be appear. Due to that only we have to use the convex mirrors only in the side mirrors of the vehicles. Yes, here some more concepts about that concave and convex also we have to discuss. Some terms also most important from here. Suppose just we have to discuss first about the concave mirror. This concave mirror, the center point, this is in a center point of the mirror that we have to know as a pole. What is that? Pole, that we have to know as a pole. A center point of the concave mirror and convex mirror, anyone also, concave and convex, the center point we have to know as a what? Pole. Yes, it is in a center point of the spherical. Center point of the spherical. Here it is in a spherical. The spherical center point. This we have to consider as a center of curvature. What is that? Center of curvature, that we have to consider as a center of curvature. We have to represent this one with C. This is center of curvature. Next one, the line which is passing through the C and passing through the P. pole mean P. Is the line which is passing through the C and P, that we have to know as a principal axis. What we have to know? That we have to know as a principal axis. Not only for concave but also for convex. Both these all terms will be similar for the concave and convex only. Yes, the line which is passing through the C and P, that we have to know as a principal axis. Which axis? Principal axis. That we have to remember. Pole we got, and center of curvature we got, and the principal axis we got. Next one, the distance between P and C. The distance between P and C, that we have to represent the symbol with R. This we have to know as a radius of curvature. What is that? Radius of curvature. What is that? Radius of curvature. Next concept. Half of the distance from the center of curvature to the pole. Half of the distance, that's mean R by 2. R by 2, that's we have to know as a focal length. Small f we have to represent as focal length. That point we have to know as a focus. That point we have to know as a focus f is exactly off distance from the C to P, exactly off distance. Suppose 6 centimeters are there, exactly 3 centimeters is capital F. Is we have to know as this one focus. Is focus, that means R by 2, that is a small f. It we have to know as a focal length. That we have to know as a what? Focal length here. That means P to F. P to F, the distance between P and F, we have to know as a focal length. That we have to represent with the small f, is exactly at off distance of the P and C, that we have to represent with the focus, that is with the capital F. That is with capital with F. Finally, we got the terms. One only pole P, yes, again one only center of curvature, again one only radius of curvature, again one principal axis, again one f focus, again one small f focal length only. Yes, first one pole P, next one center of curvature C, again one radius of curvature R, again one focus F, again one focal length small f, again one principal axis, again one what? Principal axis. Is in the next class we have to discuss the different kinds of the images from the different distances, and its properties also we have to discuss in the next class. Thank you so much.